So we are into the second half of the semester now. Everything we've done so far was descriptive statistics. Now we're doing predictive statistics. We're trying to make predictions about entire populations. And that's going to be confidence intervals and hypothesis tests. And everything we do for the next couple of weeks is all proportions. Test 3 is all proportions. Test 4 is all means. So we do confidence intervals and hypothesis tests for proportions for 1 and 2 groups. So we have 4 different kinds of problems that'll be on test 3. Then all the same thing for means. Confidence intervals, hypothesis tests, 1 and 2 groups, 4 different kinds of problems for means will be on test 4. And then the final will cover everything. Pretty soon we'll start talking about scheduling your final exam, because your final is also proctored. So take very good notes, excuse me, on confidence intervals here. And remember, like, you can go here to the module, and I post all this extra stuff. I don't think a lot of students realize this. Here are all my notes. Here are a bunch of extra videos. We open this up. Like, feel free to download this. Feel free to use this while you're doing the homework. Okay, let's do some extra examples. So a couple of these are homework questions. And then the last one is you have a homework question like it. Okay, so we got this problem. I'm going to write up complete solutions here instead of just calculating these 3 numbers or 4 numbers. You're going to have some written assignments where you have to write up complete solutions. On the final, you're going to have to write up complete solutions. You got group assignments. We got to get in the habit of writing complete solutions. So let's do that here. First thing we want to do is figure out what we're calling success and what we're calling our population. Let me write those in the other order. Population and success. So we're told here, in a poll of voters, this many did something, planned to vote for this guy. So my population is a group, not a number, is voters, technically likely voters. Not these likely voters, that's my sample, that's just a sample. My population is all the voters, and I took a sample of 650 from that population. And success is they're going to vote for this guy. Or plan to vote for him. Then we can define our variable. We write that out to help us write this. Let P be the proportion of them that did that, of the population that's successful, of voters that plan to vote for him, plan to support him. Okay, then we have our sample statistics. There are always 3 numbers. They're always going to give us 2 out of the 3. X is the, if you don't know what the letters stand for, you're going to do so bad on all the tests. You got to learn what all the letters stand for. X is the number of actual successes in the sample. How many in the sample, a whole number, did success, whatever that is. In this case, 338 said they're going to vote for this guy. That's my number of successes. N is that literally since day one in his sample size, 650. P hat is always X over N. So what do we get there? 52%. So 52% of the sample said they would vote for him. So what's the real answer? What's P? That's who we're trying to find, is P, the real proportion of the entire population that'll vote for him. Okay, so right there, that was the first question right there. We've gotten that. Now, how are we going to answer these? Find the margin of error and then find the confidence interval. We got a couple of choices. We could do this the long way. There's nothing wrong with it. Like, I'll go ahead and go through it the long way. But then we could use a shortcut. We could use the calculator. So I'll go through it using the calculator too, and you'll see it's much quicker to just use the calculator. So the first thing we'd want to find is our standard error, square root of P hat, Q hat over N. So we're going to have to find Q hat, but that's always 1 minus P hat. That would be 0.48. And N was 650. All right, so let me throw that in the calculator. .01, well, that's definitely going to round up. So I'm just going to call this 0.02. Then our margin of error is our appropriate Z star times the standard error. For 95%, you got this list. It's in that document I just showed. You don't have to memorize these numbers. But the Z star for 95% is 1.96 times 0.02. I'm just going to take that last answer, just times 1.96, and we get about 4%. There's our margin of error. They rounded quite a bit there. I would have put 0.038, but whatever. Then our confidence interval is always whatever the sample said, plus or minus the margin of error. So that's 52%. Notice you always got to read the questions very carefully, whether they want you to type decimals or percentages. These want percentages. So 52%, the sample, plus or minus 4%. So minus would be 48, plus would be 56. And then our conclusion would be we are 95% confident that P, this is why we write this line here. It helps writing our conclusion that the proportion of voters that support the candidate is between, don't forget the word between, 48% and 52%. Or no, what was it? It's 56, right? We're not making predictions about the samples. I did the sample. Sample's done. I'm making predictions about the entire population. By the way, I don't think a lot of you realize this either. Like all this I'm typing up, I'm writing up here. When this meeting's over, I'm going to save this as a PDF and upload it in the announcement. So when I post the announcement, show you one. Here's one that doesn't have it. But when I post the announcement, if there are notes that go along with the video, I'll post the PDF inside here in the announcement. So you should always look at these announcements. Okay, so that's doing it the hard way. What's the easy way? So once I got to this level right here, I could have just used the calculator to do everything. So for the rest of the semester, you got to have a graphing calculator. You got to. I know a lot of you have been pushing it off or putting it off. Now's the time. You got to get one. You can. I showed you at the beginning of the semester how to get a free TI-84 free trial. So that's a 90-day. Free trial, TI-84. Right there. Like literally just Google what I did. You can install this on your computer. Obviously, you won't be able to use that during the final, but you can check out a calculator at the testing facility. You have to learn how to use this calculator because that's what you're going to have during the final. You can't use the Inspire. Some of you have asked me about the Inspire. The Inspire is not allowed. You can also install this on your phone, Wabbit Emu. It's a free TI-84 emulator. I don't like it. I don't think it works very good. I don't love it. Let me put it that way, but it'll get you through. But you can't use that on the final. But at least you'll learn how to use the calculator doing that. Okay, so I will type all this into my calculator. I'm going to go stat over to tests. For the rest of the semester, we're going to be here in tests. Now I got to figure out which button to use. For test 3, everything is proportions. You're only going to use buttons 5, 6, A, and B. Write that down, 5, 6, A, and B. Those are all the proportion buttons. Say 5 and 6, they say prop. A and B say prop. We've got 4 different kinds of problems. For the next couple of weeks, there are really only 4 problems. We've got 1 sample interval, 1 sample hypothesis test, 2 sample interval, 2 sample hypothesis test. How many samples did I have here? I only had 1 sample. There was only 1 in. Was this a hypothesis test or a confidence interval? You don't even know what a hypothesis test is yet. See, look at buttons 5 and 6. 5 and 6 say test on them. See right there, test? That's not what I want. I want my button to say prop, and I want it to say 1 because I only have 1 sample, and I want it to say interval. That's A, 1 prop interval. And look what they ask for. Like literally the same stuff I just wrote down. X was 338. N was 650. My confidence level was 95%. I hit calculate. I'm done. That's it. There's my confidence interval. Okay, so I'm going to say here from the calculator, we got the interval 0.482 up to 0.56, no, 558. So right there, I'm done. I could have answered this question. Obviously, I just would have typed, like, this is more accurate than what we got there. And that's because we rounded right here. If we hadn't rounded so much right here, we would have gotten those same numbers. So I literally could have typed that 48.2, 55.8. It would have given me credit. Now I got to work backwards to find the margin of error. So how am I going to find the margin of error? Remember, the margin of error, the shortcut is it's always high minus low over 2. The big one minus the small one over 2. So I could just do that now. Now, if I type this, I'm going to get the wrong answer. I need to do high minus low first, then divide by 2. So I like to just do the top, high minus low, hit enter, then divide by 2. And there's my margin of error. So we don't have to go through this trouble of finding the standard error, using the Z star, all this. We can, there's nothing wrong with it, but we don't have to. Okay, so I'm going to do this one only using the calculator. First thing we got to do, define our variable. So pause and read the question. Okay, we're going to have our population. We're going to have success. Population. Who did we survey? People. What was success? They like dogs. So now we define our variable. Let P. Okay, now we're going to have our sample. Every sample is going to have an X, an N, and a P hat. They're always going to give you 2 out of the 3, and you got to find the third. All right, so we got 430 people. That's my sample size. That equal sign was ugly. They didn't give me X. They gave me the percentage, the sample success rate, 0.16. So how am I going to find X then? Think about this for a minute. 16% of the sample said they like dogs. X is how many people said they like dogs, the actual number of people. What does the word of mean? 16% of 430, of means times. X is always P hat times N. So 0.16 times 430. $68.8. Okay, look, we're going to do this on the calculator. We got our numbers. We only need a couple of numbers. We go stat over to tests. And again, this is number A, right? One prop interval. For X, we got 68.8. For N, we got 430. Our confidence level, it's right there, was 90%, so 0.90. And I want you to watch what's going to happen on the calculator here. Something weird's about to happen. We get an error. What did we do wrong? It's right here. X is number of successes. You can't have 0.8 people. X must be a whole number. Make a note of that. In my face-to-face classes, during this test 3, we're sitting down, everybody's taking the test. At least 2 people will walk up to me They'll point their calculator at my face and go, my calculator's broken, fix it. And I'll hint to them and tell them, you can't have half a person. That's the only hint I give them. I'm not going to be there when you take the final. I'm not going to be able to give you that hint face to face. Your calculator's not broken. X has to be a whole number. We have to round. And just use normal rounding rules here. And you might be thinking, well, then aren't I going to get the wrong answer? No, you're actually not rounding. This was rounded. Whoever gave us that number, that 16%, they rounded. What they actually found was 70 people in the sample said they like dogs. And then they divided to get this and they rounded that. We're just undoing their rounding. X has to be a whole number. So if I go back in there and I fix that, I go down to A, put in 70. Hey, there's my interval. And look, there's that p hat. That's what it really was. They just rounded to 0.16. So I'm going to call that 13.4 to 19.2. Okay, there's my interval. Like, that's it. That's literally the entire problem, or at least that's all the math. Now I got to do the hard part and interpret that. What does that mean? We are 90% confident that between 13.4% and 19.2% of people like dogs. I forgot to define my variable. Oh, no, it's right there. Of people like dogs. Well, whoever made up this problem, like, just made up numbers, didn't they? I'm sure more than 20% of people like dogs. Like, everybody likes dogs, right? Okay, now we still haven't answered their question. Their question was, what's the margin of error? Now, we could have done this. We could have found the standard error, found the Z star that goes with 90%. That's what, 1.645. I don't know. It's in that document. Absolutely. We could have found the margin of error using these formulas right here. It's much easier, though, to use the calculator and then just say, we've got our interval. The margin of error is half this width. Remember, when you find your confidence interval, you've got p hat. You go up one margin of error to get your high. You go down one margin of error to get your low. So the entire interval is 2 margins of error wide. So we just find that distance, how wide is this interval, and divide it by 2. So margin of error, and it's margin of error. Maybe I say it too quickly, but I hear a lot of you say marginal error. Margin of error. High minus low over 2. So 0.192 minus 0.134 over 2. And either you need to put that top in parentheses or just do the top. I'm lazy. I think this is quicker. Just type in the top. I hit enter, then divided by 2. 0.029. And then we got to be careful and see if they want a decimal or if they want percentage. And they wanted a decimal, so I would type in that. Okay, one more problem. Now we're kind of working backwards here. You have a homework question like this. I'm going to edit this problem at 95% confidence. That was a question. So this is all of this is real world. Anytime, like, it's almost voting time. We have like 19 days until the election. Any poll you hear about one candidate leading another, like everything to do with elections. When we're making predictions about what we think is going to happen, they're using this exact math. It's not like there's some fancy version of this that we don't teach you. This is literally the math that's being used right now. And you may be getting phone calls from companies doing surveys to see who you're going to vote for. Those companies need to decide ahead of time how big is their survey going to be. Because they like, for some reason, we really like that plus or minus 3%. You hear that a lot. You know, candidate A is leading candidate B by 7 percentage points, plus or minus 3%. That 3% is picked on purpose. They pick a particular sample size to make sure they're going to get a margin of error of 3% or less. And here's the math they go through to do that. So they decided ahead of time what they want their margin of error to be and what they want their confidence level to be. So remember, recall, I just wrote it up there, the margin of error is some Z star times the standard error. And the standard error is square root of P hat Q hat over N. So we want the margin of error to be less than or equal to 3% or 0.03. So we're just going to solve this for N. Problem is we don't know P hat and Q hat. If we knew those, we'd already do the sample. So maybe if we've done samples in the past and we got a good idea what these two numbers are going to be, we could use that. But if we're starting a brand new sample, we don't know P hat and Q hat. So we do worst case scenario. What numbers would be here that would make the margin of error the biggest it could possibly be? And those would be 50-50. So the worst case would be if both of these are 0.5. Anything less than that, if P hat is bigger than 0.5, then Q would be less. Anything different than 50-50, support, whatever, would make the margin of error smaller. So we're just looking at worst case scenario. So then that means we're trying to solve Z star 0.5 times 0.5, all under the square root here over N, is less than or equal to 0.03. Now Z star, what's our confidence level? 95%. So that's in our table. Again, you don't have to have that memorized. I've just done this so long. I know that one. I can never remember the one for 99%. Those are in that document. Make sure you wrote them down in your notes. But this is the one for 95%. So I'm trying to solve 1.96 square root of 0.5 times 0.5 over N less than or equal to 0.03. So this is really just an algebra problem. And to be honest, this is the hardest algebra problem we do all semester long. Now I'm going to do this in general. So I'm not going to like multiply anything out yet. I just want to type everything in at the calculator at the end. And I'm also going to get a formula that you can then just use when you have a homework problem that's similar to this, but it doesn't use 3%. It uses 4% or 2%. It uses a different number here. So you'll be able to just use my final answer and just change that. So how would we solve this? First, I would want to get rid of that 1.96. So divide it over. Now, how do I get rid of a square root? I square both sides. Everybody's positive, so I don't have to worry about flipping over this radical or anything. So the square root and the square, those will cancel each other out. Okay, now I'm trying to get this n by itself, so I would multiply the n up over here. And then that number is multiplying in to get n by itself, divide this over. To n needs to be bigger than whatever, excuse me, whatever this is. So I'm going to write that the other way so that it looks prettier to you guys. So n needs to be bigger than or equal to this number right here. Okay, so let's throw that in the calculator. Now we're going to have to be really careful here. Typing this out. 0.5 times 0.5. Let me put even the top in parentheses, even though I don't actually need them here. I just want to throw in, make sure I have enough parentheses. Divided by, I need parentheses here, and I'm going to need that entire bottom squared. So 0.03 divided by 1.96 squared. And we get that. So that says n is greater than or equal to 1067 point, I think it was 1 something or other. 1. So n has to be bigger than this. N has to be a whole number here, and we can't just use normal rounding rules. Up here when we had that issue with x, we just use normal rounding rules. This is different. N has to be bigger than 1067.11, and you can't have 0.11 people. We have to round up here because it says bigger than. So we have, no matter what decimal was here, we have to round up. So n must be at least 1068 to make sure the margin of error is less than or equal to 3% at 95% confidence. Okay, you got a homework question that's like that. I'll show you which one. It's number 9. Got a lot of homework questions, by the way. Yep. Now, a couple of things are going to change here. That says 4%, and that says 99% confidence level. So you're going to have a formula that looks a lot like this, but you're not going to have 3% there, and you're not going to use 1.96 there. You're going to need the Z star for 99%. Okay, hopefully you can figure it out from that. And that's a good place to stop.